Welcome to Ucademy and question number 10 in our series of trigonometry worked out examples. Today we are going to talk the walk. Question number 10, it reads like this. A person walking on the level path, the vertical component of the force exerted by the foot on the ground is given by force F equals capital A multiplied by cos bt minus small a cos 3bt, where t is equal to time in seconds and capital A and small b are positive real numbers, that is they are greater than 0, and the small a lying between 0 and 1. There are three questions here. Show when t is equal to plus or minus pi by 2b, the force F equals 0. Then question number 2. Given F is maxima or minima when sin 3bt equals 3a sin 3bt, write the solution in the interval t equals minus pi by 2b to plus pi by 2b for small a equals 1 divided by 3. Then the third question, calculate the maximum force F max in this interval, that is t equals minus pi by 2b to plus pi by 2b in terms of capital A when small a equals 1 divided by 3. Let me explain the physical meaning of the question. Let's imagine that I am just taking a stride. I am just keeping my left foot forward and the left heel is just touching the ground. At that moment, the entire body weight is supported by my right foot. Therefore, the force exerted by my left foot is 0. So that's the position which I have drawn here. And the time t is taken as minus pi by 2b. And as I take the stride, when the stride is complete, I am taking my left toe out of the ground. So at that point also, the entire body weight is supported again by the right leg. Therefore, at that point, the force exerted by my left leg is 0. So that's the position which I have drawn here. And that time is taken as t is equal to pi by 2b. Now, as you can see, when t is equal to minus pi by 2b, that is when the heel is just touching the ground, force is 0. And when t is equal to pi by 2b, when the toe is just lifting from the ground, the force is 0. And in between the strides, the force behaves in this fashion. That is, the force starts from 0, it goes to a local maxima, then goes down to a local minima, then again goes up to a local maxima, then again goes back to 0, and the cycle continues as I walk along the straight path. Now, using this information, we have to answer these three questions. And what is important to note is the force will behave differently based on the value of A. Let's say that I am a very stout person and the force which I am exerting on the ground is very large. Then the maximum will go up, the curve will extend like this. And if the strides are long, then this time period will extend. And if the strides are small, the time period will compress. So using all this information, we are going to solve these three questions. I'm going to rub this and start in a fresh screen. Let's go. Let's start with the calculations. The only toolkit I'll be using in this whole calculation is, since there is a cos 3bt, there is cos 3x, and a sin 3bt, sin 3x, I might use the sin 3x and cos 3x formula. Let me write down the formula here. Sin 3x is 3 sin x minus 4 sin cube x. Similarly, cos 3x. Okay, so I might require this, so I'm just writing it down. Let's start with question number 1. We have to show that force F equals 0 when time t equals plus or minus pi by 2b. So what we have to do is substitute t equals plus pi by 2b and minus pi by 2b into this equation and see whether F is becoming 0 or not. First, let us substitute t equals plus pi by 2b. That implies force F equals A multiplied by cos B. In place of t, I have to write pi by 2b minus A cos 3dt. So again, in place of t, I have to write pi by 2b. Okay, now here b and b is getting cancelled, and here also b and b is getting cancelled. Now cos pi by 2 is 0. Similarly, cos 3 pi by 2 is also 0. Therefore, force F is equal to 0. A multiplied by 0 minus 0 equals. So force F equals 0 when t equals pi by 2b. When t equals minus pi by 2b, the situation is same because cos of minus x is cos x. So like before, b gets cancelled. You have cos of minus pi by 2 and cos of minus 3 pi by 2. Both are zeros. So therefore f equals 0. Therefore we have proved that f equals 0 when t equals plus or minus pi by 2b. So question number 1 is done. Let's go to question number 2. Let's go to question number 2. Let me read the question for you. Given force F is maxima or minima when sin bt equals 3a sin 3bt. Write the solution in the interval t equals minus pi by 2b to pi by 2b for small a equals 1 divided by 3. Remember, the interval is fixed. We want the solution in this fixed interval. But as the value of a, b and small a changes, the period of the graph will change. Whereas I want a solution in this fixed interval. Clear? Let's go. I'm going to write f max per min condition. That is, force maximum or minimum condition is sin 3bt equals 3a sin. Now we have to solve this trigonometric equation. We have done it before, so let's adopt the same method. Now a equals 1 divided by 3. So 3a will be 1. So that makes our job much simpler. Let me rewrite this equation. I am replacing a with 1 divided by 3. Okay, 3 and 3 get cancelled. So you are left with only sin 3bt minus sin bt equals 0. And I am going to use the sin 3x formula. So I am going to use the sin 3bt formula. So this becomes 3 sin bt minus 4 sin cube bt minus sin bt equals 0. Now let me factor out sin bt. Now we have 3 sin bt minus sin bt. That will give me 2 sin bt. So if I factor out 1 sin bt, I will be left out with now 4 sin cube bt. I am factoring out sin bt, so I will be left out with 4 sin square bt. Now let me factor out 2 from here. I could have factored out 2 sin bt directly, but I just wanted to go step by step. So let me factor out 2 here. Now we have 2 sin bt multiplied by 1 minus 2 sin square bt equals 0. 2 is definitely not equal 0, so we can leave out this 2. Okay, so sin bt multiplied by 1 minus sin square bt equals 0. Now either sin bt equals 0 or 1 minus 2 sin square bt equals 0. So we will have a set of solutions. So you have either sin bt equals 0 or 1 minus 2 sin square bt equals. Let's solve for sin bt here. This will give me 2 sin square bt equals 1. Therefore, sin square bt would be 1 divided by 2. Take square root both sides. Sin bt would be plus or minus 1 divided by square root of 2. It's a simple algebra, that's why I'm not writing the steps here. Okay, so we have sine bt equals 0 and sine bt equals plus or minus 1 divided by square root of 2. And we need the solution for bt. And for that, as usual, we are going to use the graphical method. Let me pull out the graph of sine bt and y equals 0, y equals plus 1 divided by square root of 2 and y equals minus 1 divided by square root of 2. And look at the points where the lines are intersecting with the sine bt curve. And here it is. Okay, here we are. So these are the curves for y equals sine bt, and this is the line for y equals 1 divided by square root of 2. So this is our line. So this is y equals 1 divided by square root of 2. Then we have y equals 0. We have to look at y equals 0 also, because we need the solution for sine bt equals 0. I'm not going to draw the line because it's just along the x-axis. Next, let us go to y equals minus 1 by square root of 2. Okay, so this is the line y equals minus 1 by square root of 2. Now, we need to find the solutions, that is the principal value solutions. The principal value solutions are between the interval minus pi to plus pi. Let me mark the interval minus pi to plus pi. So this is the principal value, interval minus pi to plus pi. So we have to look at all the intersects of these three lines with sine bt curve between minus pi to plus pi. Let's mark the intersects. The line y equals 1 divided by square root of 2 intersects the sine bt curve at pi by 4 and 3 pi by 4. And y equals 0 intersects at origin O. Then y equals minus 1 divided by 2 intersects at minus pi by 4 and minus 3 pi by 4. Okay, what does it mean? It means the solution for sine bt equals 1 divided by square root of 2. The principal values are pi by 4 and 3 pi by 4. Okay, and the principal value for sine bt equal to 0 would be just 0. Okay, next the principal values for y equals minus 1 by square root of 2. That is the solution for the principal value solutions for sine bt equals minus 1 by square root of 2 would be, so this is minus pi by 4 and 3 pi by 4. Or rather minus 3 pi by 4, sorry. Okay, now let's write out the entire solution set for these three conditions. I'm going to first write this general solution. Though we do not require the general solution, but it's a good practice to understand the general solutions. Okay, let me write the general solution for sine bt equals 1 divided by square root of 2. Therefore, bt would be pi by 4 plus 2 pi n, that is principal value plus 2 pi n, correct? Then 3 pi by 4 plus 2 pi n. And these can be written in a much more neat format as 1 by 4 pi plus 8 pi n and 1 by 4 multiplied by 3 pi plus 8 pi n, where n is set of all integers. Next, let us look at sine bt equals 0. The general solutions are, if you look at it, sine bt equals 0 and bt is 0 plus pi minus pi plus 2 pi minus 2 pi plus 3 pi minus 3 pi and so on. So bt equals n pi, where n is set of all integers. Next, let us come to sine bt equals minus 1 divided by square root of 2. The general solutions are bt equals minus pi by 4 plus 2 pi n and minus 3 pi by 4 plus 2 pi n. I'm going to write it as minus 1 by 4 pi minus 8 pi n and minus 1 by 4 3 pi minus 8 pi n, where n is set of all integers. Well, we have found the general solution. What about the solution within the interval minus pi by 2b to plus pi by 2b? Before we proceed, I would like to clarify something about the interval. What is our interval? Our interval is minus pi by 2b, that is time t is between minus pi by 2b to plus pi by 2b. Since our equation sine dt is in terms of dt, I can write the same interval as bt is between minus pi by 2 and plus pi by 2. These two are one and the same, no difference. Now let us go to the solution for our interval bt equals minus pi by 2 to plus pi by 2. So this is the sine bt curve at a much tighter interval of minus pi to plus pi. First, let us mark the required interval. We require the solutions in the interval bt equals minus pi by 2 to plus pi by 2. Therefore, we require the solutions in this interval. Therefore, bt is between pi by 2 and minus pi by 2. Let's look at the solutions. The intersects of y equals 1 divided by square root of 2 and y equals minus 1 by square root of 2 are. So these are the intersects. We have one here, another here. We should not forget sine bt equals 0. So that intersect in our interval is at the origin 0. Therefore, the solutions are pi by 4, minus pi by 4 and of course 0. Okay, so we have three solutions. That is minus pi by 4, 0 and pi by 4. Let me write down the general solution here. The solution set for sine bt equals 0 and sine bt equals plus or minus 1 divided by square root of 2 is 0, pi by 4 and minus pi by 4. So this is the answer for our question number 2. Let's return to the whiteboard. Cool. So we have the solution set for sine bt equals 0 and sine bt equals plus or minus 1 divided by square root of 2. And the solution set is the solutions for sine bt equals 0 and sine bt equals plus or minus 1 divided by square root of 2. The solutions are 0, pi by 4 and minus pi by 4. So this is bt equals 0 and bt equals pi by 4 comma minus pi by 4. And remember, in the interval bt lying between minus pi by 2 to plus pi by 2. Now, are we done? Not exactly. Out of these three, which is minima, which is maxima? How do we know? Because we have to get the value of f max in terms of a. Okay, which is minima, which is maxima? Okay, I want to tell you pi by 4 and minus pi by 4 are maxima. So these are the maxima points. And bt equals 0 is the minimum point. Okay, now the complete proof of maxima and minima for this equation you can watch here. The calculus solution you can watch here. So that completes our question number 2. Let's go to question number 3. Let's look at question number 3. Question number 3 is calculate f max, okay, in the interval bt equals minus pi by 2 to plus pi by 2. where A equals 1 divided by 3. Okay, and we need the answer in terms of capital A. Let's look at the F. F equals A cos bt minus A cos 3bt. Now, for F max, we have to substitute bt as plus pi by 4 and minus pi by 4 because at these 2 points it is maximum. The force is maximum at bt equals plus pi by 4 and minus pi by 4. So F max equals F max at bt equals pi by 4. Let's do this calculation. So A multiplied by cos pi by 4 minus A cos 3 pi by 4. We know these values. Cos pi by 4 is 1 divided by square root of 2. Cos 3 pi by 4 is minus 1 divided by square root of 2. And A is 1 divided by 3. Okay, let's simplify this. Minus of minus is plus, and I can factor out 1 divided by square root of 2, right? So, A divided by square root of 2, this is 1 plus 1 divided by 3. So, this will give me 3 common denominator, 3 plus 1, 4, 4 by 3. So, A multiplied by 4 by 3, and of course, we have square root of 2. Now, this can be simplified further a bit. We can remove the radical from the denominator. 4 I'm going to write as 2 multiplied by square root of 2 multiplied by square root of 2. So, this is A multiplied by 2 multiplied by square root of 2, square root of 2, the whole thing divided by square root of 2 multiplied by 3. So, square root of 2 get cancelled. So, we have F max as 2 square root of 2 A divided by 3. Now, we have to apply bt equals minus pi by 4 also, but the answer will not change because cos of minus x is cos x. So, cos pi by 4 and cos minus pi by 4 are one and the same. Similarly, cos 3 pi by 4 and cos minus 3 pi by 4 are one and the same. Therefore, F max will have only one answer, that is 2 square root of 2A divided by 3. So, this is our answer. Okay. So, we have done all the 3 questions. Okay. So, please subscribe to Ucademy and don't forget to opt for notifications. Thanks for watching.